Hey everyone, it's James again, and this time I'll be going over the art of stat distribution's fine percentile section in the normal distribution. As a quick recap of the last video, we used fine probability section to confirm our understanding of the empirical rule and find questions to answers like what people are paying on the price of flight tickets. If you don't have the app yet, you can get it by going to the App Store and typing in Art of Stat Distributions, and it should be the first result for you. If not, it should be among the first three, and when you have it downloaded, it should look like this here, and we'll open it up and head back to the normal distribution for this video. One of the biggest places in the world that you'll hear the term 95th percentile is in your high school GPAs or test scores. Usually when you receive back a lot of standardized testing, you'll also receive information on what percentile of scores your score fell into. With this in mind, let's actually use a real-world example and use the FCAT's real mean and real standard deviation to find some information regarding the percentiles on the FCAT scores. At the bottom of the page, remember we have explore distribution, which we've been using, find probability, which we used in the last section, find percentile, which we're going to use now, and simulate numbers, which we'll go over in a little bit. Let's move past the find probability section and head over to the find percentile section for these questions. So, the real score and real mean on the FCAT test, according to the internet, is 50, so let's put that in, with a standard deviation of 21.06. 21.06. With this in mind, we can start to answer some questions that we may have about the FCAT and what percentages and percentiles people fall into. So, let's say we'd like to know, well, what score do 95% of students score less than? So when we're talking about scoring less than, we're going to be using a lower tailed test in order to figure that out. So when I said 95% of students score less than the score, we need to put in the percentage of students that we want to know who scored less than the score, 95, and lower tail. We come to the conclusion that 95% of students in the FCAT tend to score less than 84.64, meaning that you are the top 5% if you scored more than that. Some may also refer to this as the top 5th percentile. It's an interesting way to put it, and some refer to it as you are above the 95th percentile, you're the top 5th percentile. There's a lot of ways that people put it, but they all mean the same thing. You scored better than 95% of other students, and that score in this situation being an 84.64. On the other end, we may want to know, well, what score do 60% of students actually score more than? And when we're talking about more than, we're going to be changing our type of probability from lower tail to upper tail, because we said more than. In our lower tail circumstance, we use the words less than. And we said, what score do 60% of students score more than? So let's go with 60% of students score more than this score, with that score being a 44.66. And I'm glad 60% of students score better than that, because that's quite low. We can also find things that are called quartiles. So if we'd like to know, well, what number or what score did 75% of students get less than and 25% of students got more than? So we'll put that in. We'll put that in as, it doesn't matter really for lower tail or upper tail, but let's head back to lower tail. We need to put in 75 for students scored less than this. So the third quartile is a score of 64.20, meaning 25% of students scored above and 75% of students scored below. Later in your statistics courses, you might have to compute confidence intervals, and you'll have to find certain percentiles of the normal distribution. So let's go back to the standard normal distribution by setting our mean to 0 and our standard deviation to 1. Let's find the correct percentile so that 2.5% of values are in the upper tail and 2.5% are in the lower tail. So let's start with the easier question of the lower tail. Once we have it set up here, we can see that 2.5 on the lower tail is going to give us a score of negative 1.96, and this is going to be a really important number to you. If we'd like to figure out how to get 2.5 on the bottom and 2.5 on the top at the same time, we have to use a thing called the two-tailed test. So we need to change our type probability to the two-tailed, and we need to set, remember we said on the bottom 2.5 and on the top 2.5. When added together, that's going to be about 5%, which gives us negative 1.96 on the bottom and 1.96 on the top, meaning that we are 95% confident in the middle. This is important for confidence intervals and will be when you're finding percentiles of the normal distribution in the future. For the very last thing that I'd like to really go over is the simulate number section. This is a really great new addition that can kind of put things into perspective for you. Suppose you want to simulate, well, what kind of prices you could get for plane tickets, and you could do that again in the simulate number section. So let's go over to the simulate numbers. Instead of using the standard normal, let's change it back to our flight example with the mean 100 and standard deviation 0, and we could simulate what kind of prices we'll be getting. So we press the simulate, and simulate, and simulate, and simulate. And we can scroll down and we can see the prices of every single flyer and what they paid for their ticket. And we can see at the bottom some descriptive statistics about each sample, what their means are and standard deviation. And this could really give you a perspective on what we're doing and how it really shows up. There are many different distributions that follow the same logic for finding percentiles and exploring them, and we'll be tackling them in other videos. The next video in this series is going to be about binomial, and we'll eventually go over some inference. So I hope to see you there, and I hope this has been really informational about the normal distribution.